Now we want to look at increasing and decreasing behavior of our y equals x squared plus x function. Here's a graph of that function. Here's a table for that function, the table we made earlier. Now, what do we mean by increasing or decreasing? Well, if we start with the x squared plus x, the y value 0, we get y value 0, 3/8, 2, 12. Those values are clearly increasing. So it appears from the numbers that we have here, and of course we could, there could be other numbers where things get a little weird, but it doesn't really happen with this function. From the numbers that we have here, it appears that at least starting at x equals 0, this function increases. Okay, the numbers are continuing to increase. Now, from -4 to 0, as x goes from -2 to -1, the value of the function goes from -4 to 0. Is that increasing or decreasing? Well, that's increasing because 0 is greater than -4. Then we go from 0 to 1/8, we're still increasing. So for these three values, the function appears to be increasing, but then what happens? It decreases to 0, and then it starts increasing again. So it looks like the function is increasing, it's increasing, but something happens and now it decreases, and then at some point it turns around and starts increasing again. And we're not really sure where it turns around. Does it turn around just after 0? Does it turn around a little before 0? Does it reach its maximum value at -1/2, or does it peak somewhere else? The graph of the function reveals the same behavior. This is a graph as we constructed it. It's much like the graph that we constructed over here. Not a perfect copy, and the graph looks a little pointy there. It's supposed to be pretty smooth when it turns around at the origin. It appears that the graph is increasing, and when x is 2, we're at -4, y is -4. When x is 1, y is 0. And when x gets to 0, y is again 0. But when x is at -1/2, halfway between -1 and 0, the graph is above the x-axis. So there's at least one peak of the graph in here. Now we don't know how many peaks there might be. If we evaluated this at many points in between 0 and 1, we might find that there's more than one peak. Turns out that there aren't. There's just one. And it kind of looks, especially the way I've got it drawn, like that peak probably occurs when x equals -1/2, and that the peak occurs then when y is 1/8. However, I believe that the peak in fact occurs when x is -2/3, not at 1/2. But to get that, you have to use calculus. And then, we're a long ways from that. So we're not going to worry about exactly where it peaks. All we're going to worry about is the fact that we have increasing behavior, but then we reach a peak and the graph decreases for a time, and then it turns around and increases, and we have good reason to believe it just continues increasing after this. For example, after we reach 0, x values are positive. And if x values are positive, then both x squared and x are positive, which means that the graph can't go down below 0 after it hits the 0, after it hits the point 0, 0 here at the origin. Excuse me. I also realized I never wrote the cube here. This is x squared plus x cubed. I hope that didn't confuse you. The other thing is then that as x gets bigger, if x is positive, then if x gets a little bigger, x squared gets a little bigger, and so does x cubed. So certainly x squared plus x cubed is going to get a little bigger. So that this graph, these values are going to continue to increase. As x increases, the values increase. Now the question is, on what intervals does this graph increase, and on what intervals does it decrease? Now what do we mean by intervals? We mean x intervals. Well, let's first look at the graph. Okay, where is this graph increasing? Well, it appears that the graph is increasing. Let me use a color that contrasts with green just a little better. The graph is increasing here, and it's still increasing, and it's still increasing, and it's still increasing, but right at some point around here, it looks like it peaks and stops increasing. Then, of course, it starts increasing at 0 and just continues on increasing. So it appears that for x values from about here on, the graph is going to be decreasing. Now we can reason out numerically that since cubing x gives you a bigger result than squaring x does, or at least gives you a bigger absolute value than squaring does, the positive number you get when you square a big negative number is not going to be as big as the bigger negative number you get when you cube it, so that x squared plus x cubed will be negative, and there are other arguments you can make that show that this thing will just have to keep decreasing as we move through negative values, to bigger and bigger negative values. Okay, so the function is increasing here, and it's increasing here. But there is a short interval on which it's decreasing. So it decreases on this interval, it increases here and here. Now, how would we write those intervals? Not knowing the details of the calculus, you probably wouldn't conjecture that this thing peaks at 2/3, negative 2/3. You'd probably conjecture that it peaks at negative 1/2. Just a conjecture. It turns out it's not quite true, but it's close enough to give you the idea. So it may be, well, it appears that we're increasing on the interval from negative infinity to negative 1/2, union the interval from 0 to infinity, because those are the intervals that we've indicated by the purple arrows. And that it's decreasing, and where'd my red chalk go? It's decreasing the interval negative 1/2, 0. Okay, well, your text is going to ask you questions about functions that are increasing and decreasing, but this should give you the idea of what that means and what we mean by the x interval on which a function is increasing or decreasing.